a key part in. Before we get into the latest news making headlines, we have a brief discussion right here, and we well know of the importance of travel, especially air travel. And I was just looking at the statistics. I happened to Google the number of crashes that have happened in just this year, 2022 so far. And according to Aviation Safety Network, they said in 2022 there have been 9 accidents and 202 fatalities in total. One life is too many. So we want to have a discussion all to do with air safety, and especially if you happen to be a common user of planes, this is definitely hitting close home. And we happen to have the presence of 2 individuals from Star Navigation, which is based in Canada. They came all the way, and I'm pretty sure they boarded a flight. So it definitely brings a point home in terms of air safety. I'll introduce one of them as captain. Perhaps he'll correct me if I'm wrong. Jonathan Cordich, who's the Executive Vice President at Star Navigation Canada. Jumbo.
Jumbo.
It's great to have you with us. Karibu Kenya, and welcome to KTN News. It's a pleasure to have you with us. Equally joined by Hamid Gill. I hope I pronounced it correctly.
Perfect.
Thank you so much. He is the Director of Investor Relations at Star Navigation Canada. And I think we'll start from an informative point of view. And as I was researching for this particular conversation, I happened to come across the mythical Bermuda Triangle. And it's well known about how certain planes, ships happen to disappear right there. So as we bring the point home, kindly break down this narrative. In terms of air safety, Bermuda Triangle, what exactly happens there? Perhaps let's start with you.
The Bermuda Triangle. Wow, that's interesting.
Yeah.
I believe the Bermuda Triangle is between Bermuda, Miami, and
somewhere up there. It's a triangle
Puerto Rico.
somewhere.
Yeah. And Puerto Rico.
That's right.
Definitely. Well, is it a myth or not? You know, that can be a long story. And I certainly don't intend to do that.
Yeah.
But more in the past than now. As far as aviation is concerned, that Bermuda Triangle today, in terms of aviation, does not exist. But in the past, in that particular triangle, we have lost aircraft, and we have also lost boats and ships.
That's right.
That is actually factual, and the reason for that, because of the geographical location and the distances between Miami and Hamilton in Bermuda, and
Costa Rica.
San Jose. It's Puerto Rico.
Right.
Jose. Those are the actual and exact dimensions. Because of the vast triangle, in the past, due to the lack of navigational instruments capabilities, the potential for getting lost in that triangle was very high. As the technology has grown for airplanes and also marine-going vessels, today, it's very, very rare that something like that happens. And if it does happen, it's normally allocated, to human error. In the past, it was considered to be the mythological triangle only because of weak navigational signals, and this kind of air and marine vessels would get lost, and in such a vast area, unable to be found.
Okay. Well, it's the 21st century, and we're talking about the latest technology being used in these planes. But as I mentioned, the statistics sort of prove otherwise. Despite having the latest in terms of technology, we still have accidents that are happening and claiming lives. We've talked about black boxes and how important they are. Perhaps from your point of view, what can we do in terms of advancing technology and whatnot to ensure that the frequency of accidents is actually brought down?
Well, one, the black box is a very old technology. The person who actually invented it passed away at the age of 85, some 7 to 10 years ago.
Okay.
So it is really, really old school.
Yeah.
It gives you a limit of parameters from the aircraft, maybe 200, 300 parameters that you'll get out of it. How our system differs coming from Canadian technology, Canadian parts, we don't put parts that are going to affect the airline industry at all. They're all high-class parts, and Canada is known for that. So our certifications are very strict, so this is very important. Now, our system will actually, if you look at the aircraft from power on, throughout the whole flight phase to power off, it's monitoring it right from the time it started. So it's a virtual window into the aircraft.
Okay.
So the ground personnel actually helps if something is detected. So if you have a problem with your left engine, it tells you now, not when it's too late. So if you look at the current system right now, we call it a reactive system. So by the time this plane goes and it's coming for a landing, they extract the data and they put it on the engineer's desk, right? Now the engineer has to check it. It could take him 7 hours, 10 hours to check what happened to that particular flight. Let's say it's coming from England to here, or UK to here.
Yes.
Now, after they've done that, 7, 10 hours later, this plane's now already flying. And they figure out something's there. Now on the flip side, the engines are the most critical. The engine monitoring condition, it goes to a third party, and you get the reports back in about 3 weeks or so. Same with the fuel management systems. You get what I'm trying to say here? We have a Malaysian MH370 that's been missing since 2014. That's 8 years, 240 passengers, 777. It was nowhere a small caravan here, right? So if you look at that going missing and we can't find it, we couldn't detect it, what happened to it, it's a mystery as well, just like the Bermuda Triangle.
Exactly. So in terms of disappearances of planes, and it's proper that you brought up that Malaysian accident that unfortunately claimed lives. What should we do, perhaps in terms of technology? Is there advanced technology to ensure that, you know, despite the black box being invented a while back, when it fails, what comes in place to ensure that we get the signal of the plane in case an accident happens?
Those are good statements, good questions. You know, really, where is the starting point in terms of what can we do? What are preventative measures that we can take? Where do we start? Well, what we've had up to now in terms of technology is related to the black box. It's a system of black boxes, one with respect to the digital flight data recorders and the other one cockpit voice recorders and things like this. That those are systems that gives us the opportunities to find out what went wrong after actually the event happened, which certainly is too late. You know, the design of our new system, it is actually preventative measures so we don't get to that point. And this is what is very critical in aviation, that we need to be able not to be looking for the black boxes. We want to prevent events like this. So where do we start? Well, certainly has been, well, what is causing accidents in the first place? And up to now, and of course, you know, all of this is coming from statistical analysis, from accident investigations, so that way it doesn't happen to us again, but again, preventative measures. But you need to understand what the problem has been. And, you know, if you ask for how many reasons do accidents happen, the number could be an infinity. But the reality is there's only really two reasons why any accidents happens. It's either human error, or we call it human factors, or the other one we say, well, is the machine. You know, the design of the machine. But when you look at who designed the machine, it is certainly still humans. So at the end of the day, all the accidents that are being caused today are based on human factors. And I didn't know the statistics that you just brought up, and thank you for that. But what's hitting me hard, that's one accident a month up to the point of time that we're here here at the beginning of November throughout this year. And that is an incredible number in this day and age of technology. So, you know, here it is, accidents happen, what do we learn? What we have learned is that it is errors, mistakes that we make. And then we say, well, where do the mistakes come from? You know, nothing goes from 0 to 100. Everything that happens, it starts to develop at a certain point. And then we have been able to determine that there is a series of events, either related or not, before it comes to a point of where a disaster occurs. So what has happened in between? We haven't been able to detect what was going wrong, what was going on. And hence, we have better training programs in terms of human factors, develop a higher level of situational awareness. I think from a psychological perspective or neurological perspective, if you like to say, I think, as human people and brains, I believe we have reached our max capability. Now, what's the next from here? Well, we've been able to develop, tremendous economic development in industry. And if you look at the major economic and industrial changes throughout the world. The first revolution was the Industrial Revolution in the 1800s that really changed how the world moved. Before that, all the wars that were happening was happening because of land.
Yeah.
But once the Industrial Revolution came in, the world started to move in a different direction.
Mechanized.
The next revolution, the second revolution occurred, it started throughout the 50s, which was computerization and communication. And if you look at, when the calculator first came out, I mean, you're too young to remember that, obviously.
Yeah.
But I remember my mother said to me, don't touch that thing, because it's going to deteriorate your brain.
Okay.
We could not do without calculators. But look at the capability of a calculator.
Okay.
No human brain can match that. The numbers that it can multiply, divide, and name it,
Okay.
right?
Okay.
But we designed it. That didn't just happen on its own.
All right.
That's why I'm not leaning toward making people feel that machines one day going to replace us, because this has been on the conversation table of our airplanes going to fly themselves one
Yeah.
day. That's not going to happen. We can design them to do that, but we will still control them by whatever means is going to happen.
Okay.
And then the mobile telephones, communications came about.
All right.
So when you look at that, when first mobile telephones came out, one big box that put it on the table, the ones that didn't have it, like myself, when I first time looked at it, I said, that is just for show.
Yeah.
I don't need that, But then as the telephones
phones.
became more compact, more economical, more affordable,
Okay.
what did we do? We said, it seems like quite a few people have this. So maybe I'm just going to get one for emergency purposes. Perhaps. Just
Yeah.
in case I need it,
Flat
leave it
tire.
in my pocket, and that's it.
Yeah.
Look at us where
you
we
now.
are today.
Exactly.
See? So that's the second revolution.
Okay.
The third revolution, in which we're in today, it's a technological revolution. So what kind of technology? We're in aviation, so that's what I'm going to address. Biggest thing is getting back to preventative measures.
Okay.
So we have realized from statistical analysis there is always a series of events that go undetected, that they could be threats or mistakes we have made, and we were unable to solve them, and an incident or accident occurred. And can we develop our neurological activity to the next level, not relative to technology? Again, the calculators, the mobile phones, of what they can do, we physically cannot do that.
All right.
But we can develop the technology, and that is what star navigation has done in terms of detecting and preventing this kind of accidents.
Well, technology is definitely advancing,
Yeah.
and I think we'll talk with you about artificial intelligence and how we can incorporate this to improve air travel safety.
Perfect, and I'm glad you asked me that question there, Jesse. And the way it comes down, our system that was designed in Canada,
Yeah.
Canadian products, it takes the data buses where you have multiple data buses in an aircraft. So what we do, we extract the data. We're a big data company.
Okay.
So we extract that data and we'll give you the complete operational picture of what's going on with your aircraft. Not when the plane's landed, then you extract, right from power on to power off.
Okay.
Right, so we know what's going on with the plane. So if you have a problem with your left engine, right engine, you know now, not when it's too late. So we call this a proactive system, not a reactive system. All right?
Yeah.
If something's going to happen, and I'll give you a quick example. We all know birds. You have birds here. Every country has birds. If a bird, even a small bird, a robin, 2.9 kilogram, goes through the engine, you don't notice it. It's like a bullet hole.
Yeah.
But you're going to keep flying. You're going to keep flying. Eventually, 4 or 5 flights later, the whole engine might blow out. Now, you could have a catastrophe here because your plane is grounded. The passengers are now ticked off. Could damage something on the aircraft, plus the body of the aircraft, and it could cost you maybe 2-3 million to repair that. Our system, as soon as the bird goes through, it'll pick up the vibration surge. It'll tell you right away you have a problem with your left engine. Now you might need to only change that blade. It might cost you maybe 85,000, and plus you won't cause the delay. So these are the kind of things which are very big factors of what our technology can do. And now, if your plane is flying, and let's say you do have an incident on your left engine, N1 or N2, that's what we call it in engineering terms, but we're talking to the public here. Something goes wrong, right away you're notified. Now the ground can say, okay, satellite communication, let me call the pilot and let him know you have a major issue in your left engine.
Okay.
He might get a beacon go off or a light, but he still doesn't know what is that main
exactly
problem.
is the
But we're telling you specifically what that problem is.
Okay.
So it's very, very critical that you can use the artificial type of technology today and come across that As soon as your plane's landed, your immediate reports go to you, flight safety, flight operations. And a great example I can give you here, we were catering our Canadian troops in Afghanistan when the war was going on. We were on 32 helicopters. One incident, and it happened in a time when we were sleeping in Canada. But because our technology is so superior, we've actually programmed it that you can actually see it on your cell phone. Okay? So as long as you're authorized.
Yeah.
So right away, this helicopter is taking off from Kandahar, going to the war zone. Rotor problem happened on that helicopter. Immediately, the system picked it up. We got alerted, but they're already alerted there too. And they're already looking to the problem.
Okay.
It's Christmas now. Who's running the system? It's automated so superiorly that no one has to run it. You don't have to monitor your aircraft all the time. You'll get alerted if something happens during the flight.
Well, prevention is better than cure. What I've picked right here. But equally, ignorance is no defense. So in case I'm a flight enthusiast and I'm trying to look into ways of enhancing flight safety, or I'm just a passenger in a plane, what should I look out for as a passenger? Because you're speaking from a pilot point of view. Back as a passenger, and I hear, perhaps I'm sitting next to the engine and there's a funny noise. Should I get the jitters then, you know?
Sure, why not?
Yeah.
I mean, who wouldn't?
Who wouldn't? True.
You can't
Yeah.
run far though,
no,
but yeah, you'll get the jitters.
No, listen, Hermit is making some very good points, and you asked a really good question. You said, the way I understood you, and I will get back to your answer there. But I think this is important for your viewers to understand in terms of what the technology is and how does it actually work. Because when you say artificial intelligence, I'm sure the curiosity is very high.
True.
People want to, well, how does it actually work?
Right.
Well, it's very simple. It works fine, it lasts a long time, and it costs a lot of money. Okay? But now, to get real, what he's talking about is the foundation of artificial intelligence. It requires data from the aircraft. And again, I'll get back to your passenger scenario there because it's very, very relative. Okay? But to give you a proper good answer, in my opinion, let me address this for a moment, is that he's talking about getting all this data. And this is where the new development in technology is. This is where we have other similar company like us. I mean, we are not the only one that does this, but we are the only one that has this level of capability. The other companies, they are starting to collect data in real time right now. From engines, from other systems. We collect data from every single operating system on the airplane, including what's going on in the cockpit, or how the airplane is being flown in real time. Right now, we can see it on the ground. Anything that goes out of the normal, even before we see it in the cockpit in terms of malfunctioning indications, even before engineering maintenance determines some kind of fault throughout their required checks, this system gives us early warning. That technology we haven't had up to now. So that's a key, and it needs the data to be able to do that. So early warning. So here is the start of preventative measures. If you don't see it early, when are you going to see it? If when something goes wrong, you better stop it now. If you see a fire in your house, don't wait for it to get big. Stop it now before it becomes disastrous. So it's very simple laws of physics that are applicable here. So now that we have all this data, early preventative measures. You see if something's wrong, can we actually fix it or not? Sometimes we can't because the airplane is in the air. Certainly we have communication, we can advise, it has its purposes there. But where is artificial intelligence going to come in here now? How does it work? What does it do? It takes a principle of what we call machine learning before we get into the artificial intelligence. Machine learning is what? Calculators. They have learned to be able to multiply so much, and they can execute it very, very quick and give you an answer right there on the spot. Fraction of a second. So we have designed systems of where we believe, we can make machines think. No, we can design machines to, process information much quicker than we can. That's called machine learning. Artificial intelligence is the last step. Do you want to know about it, or you want to
just briefly, yes. Kindly,
briefly?
I'd like to know.
Artificial intelligence, now what happens in terms of accident preventative measures? Series of events occur and it comes to an accident, again being undetected. When something goes wrong, machine learning will detect it and it will show us this is what the number is. Now the artificial intelligence comes in, it has the ability, again we have designed this, that it tells you if you have this small problem now and if you don't fix it now, how long is it going to be before it goes
critical.
to a major problem? How much time do you actually have?
Okay.
That is a superiority
Priceless.
in technological development.
Well, I'm getting a picture of this. I'm feeling like a captain right now, dare I say. But anyway, in terms
You have to start as a first officer first.
Okay, fast officer. Oh, that's the hierarchy.
Okay.
Okay, thank you for that. Since I'm speaking about fast officer and whatnot, training of pilots, because he mentioned about human error, which can be a factor in some of these accidents that might happen. Talk
right.
to us about that and perhaps what you're
Training.
doing
So,
to
yeah,
enhance
we-
it.
Yeah,
and
I
global
can,
tracking
I can
as well.
start on
Yeah.
it, but I would like Cap to jump on that as well after
Okay.
that, because
Yeah.
there's a reason we became partners.
Yeah.
Okay, they are in 160, they deal with 160 airlines around the world, and they have 9 training centers. So you're looking at South Africa, they've been here about 20, 22 years training pilots, and they train some major pilots from major airlines here too, small to big. And then you got to see that the training centers are in South America, in Switzerland, in Spain, India, China. So they've got a lot of experience in this. And why they came and thought that star navigation fits the bill, because in order to train your pilots with ever-changing technology, you got to have the best technology to do that. You got parts are changing, hardware is changing, software is changing.
Okay.
So we pull all this data out and we bring it not in data coding, we bring it in plain English so you can understand it. That's one thing. 2, for the pilots to train, avionics to train, flight operations is very, very critical. Because if you have 5 aircraft, we want that to grow to 10 aircraft, right? I mean, we've been at Wilson Airport here. We've been talking to people.
Yeah.
They came to our seminars. They saw what they got. We're about to go to Ghana. We have the aviation ministers and whatnot that are going to be there. So the government officials are getting to stay with this, saying, you know what, we need to look at this more specifically.
Okay.
We had KCAA come there. The guy is also a captain pilot. When he looked at this, he spoke on TV. He said, wow, this is what we need. They've got our blessing. We want to help you guys with your next conference, but we want to see a lot more people attending, and we want to hear a lot more about what this technology can do, how we can save lives, how we can help the country grow. We want the growth of Kenya. We want to create jobs for Kenya. And
Sure.
this is all a package.
Okay. You
Captain?
can add on it.
Yeah,
Yeah.
please. That's a very good comment. Well, we train in over 60 countries worldwide with various approvals from different national aviation authorities. I have been in aviation myself for 42 years. I started when I was 2 years old. You know, so
As a fast officer.
as a first officer, yes, exactly.
Okay.
You know, and training is very critical.
Yeah.
But again, as good as training that we have today throughout the world, and quality of simulation and better programs and better documentation, name it, we have top of the line. 1 accident per month is not acceptable. 1 accident is not acceptable. So where does this lead us? Well, it's taking me back to your initial question about your passenger, their feeling. I did not forget
Cheaters.
about
Yeah,
that, because
yeah.
that's very important.
Okay.
Is because, like, if the airplane is equipped with a system such as ours, through artificial intelligence and all we have, which is called In-Flight Safety Monitoring System, ISMS. Me as a passenger, if I knew that the airplane is equipped with such a system, it is not likely that I will even get myself in a situation of where I see vibrations occurring. Now, mind you, turbulence, vibration, they can seem the same.
Yeah.
We cannot, nothing can stop the weather. Nothing can stop
Okay.
Mother Nature except us avoiding it.
Okay.
But with respect for anything going wrong with the aircraft, systems like this, again, through its capability, will not allow it to get to that point. Certainly every airline is going to say, we are the safest in the world. And certainly I agree, otherwise you won't be in business. But you cannot be as safe as you would be if you had such monitoring systems, because now you know how the series of events are developing, and you can apply their process into your training, so therefore now your level of proficiency in your training is going to be to the next level. We don't have that today.
Okay, we definitely need to do a lot in terms of improving air safety, but this is definitely a step in the right direction.
Yeah,
Thank you so much for your time, and I'm pretty sure you'll spend some time in Kenya, even as you perhaps inculcate this knowledge into our, KCAA and such authorities that play a big part in the
And
aviation
Jesse,
sector.
I would love you to come to Canada so we can teach you ice hockey,
Oh,
and then you'll be very good on your feet.
I'll take you up on that offer. Thank you so much. We were joined